Hi, welcome to lecture 6, and now we're into chapter 2 finally. So we're going to be talking about the history of astronomy, and your book covers the Renaissance astronomers quite well, and it does present the Greek astronomers, but I would like to cover the Greek astronomers in a little bit more detail. I think it gives us a lot more perspective. So I think it'll amaze you what the Greeks understood and what they knew. It's very impressive. So in fact, I want to start along those lines. I'm going to actually start with the flashcard, and I'll start with the answer to the flashcard. So I want to talk about 6 important discoveries that the Greeks made. Now, ancient Greece starts, well, for our purposes in astronomy, it's going to start around 500 BC and it'll go to about 180. So a period of about 600 years total. But most of it happened between about 300 BC to 0. So the first thing that they discovered is that the Earth is spherical. Now that doesn't mean that it's a sphere, it means that it's spherical, maybe not a perfect sphere, but its shape is closer to the sphere than any other perfect sort of figure. How did they know this? Well, they figured it out from looking at a total lunar eclipse. So let's go back to our previous lecture in a total lunar eclipse. Remember, there's 2 parts of the Earth's shadow, and we can't see the shadow, but we can see the moon moving into the shadow, and I didn't draw this very well. And so say the moon was moving in like this, and right at this moment, they would see the edge of the Earth's umbra. I'm sorry, I did that wrong. If the moon was there, I've exaggerated, they would see the edge of the Earth's umbra right here. And what the Greeks did is they actually cut out circles out of papyrus, reed, and they filled in the rest of the umbra, knowing that was the shape of the Earth. So we're not sure, this is so far back in time, we're not sure who did it. But we know who advertised it the most, and that was Aristotle. Now, it could have been Aristotle that noticed this, but he probably was just the one that advertised it. He was very outspoken. We'll put his name in parentheses. So for our purposes, we'll give him credit for this scientific discovery. Now, I'm not very familiar with Aristotle's philosophical teaching, how he was as a philosopher. He's very famous, for sure. That much I know. But I do know about his science, and I can tell you that as a scientist, he was about the worst scientist I've ever seen. He got everything not only wrong, he got almost everything completely backwards. We'll talk more about that. But it's possible he got this, which is a home run. The first human to realize that the Earth is a spherical body. So this is way before 1492 sailed the ocean blue. This is still BC. The Greeks were aware that the Earth was spherical by looking at a lunar eclipse. Okay, so some books just say it was the Aristotelians that discovered or realized this. All right, then considerably later, oh, and by the way, because they cut out these circles and lined them up, they estimated that the Earth was 4 times the diameter of the moon, which is of course correct. And they even took into account the fact that the umbra shrinks as you move farther from the Earth. And I've had El Camino students do this in our lab class. There was one semester where there was a total lunar eclipse on the night of my lab class. And I had them actually cut out circles and bring them, and they held them up and matched the curve of Earth's umbra to their circle, and they figured out that the Earth was 4 times bigger than the moon. And of course, it also showed very clearly that the Earth is spherical. Okay, but we didn't know the size of the moon, we didn't know the size of the Earth, but we knew that they were in a ratio of 4 to 1. And then came very important Greek scientist. By the way, I'm not going to present these in order, historical order. I'm presenting them in logical order, although this one did come first. So, but the next person I want to talk to you about, you probably have never heard their name, which is just amazing, considering what they did. And so it's kind of my pet peeve, and each teacher in my book gets one pet peeve per semester, so here it comes. What that means is you're not allowed to miss this question on a quiz or test. You're absolutely not allowed to. I will make funny faces at you and try to embarrass you into learning it. So this guy's name is Eratosthenes. And you're probably smiling right now because you have no idea how to spell that and you've never heard that name ever. That's my point. This guy should be in all the history books. And you've heard of Columbus, you should have heard of Eratosthenes. So most Greek names, you pronounce all the letters. Eratosthenes. I suggest you say that several times. Eratosthenes. Even if you don't like history, this is not irrelevant history. This is a gap in your knowledge. You need to know this guy. He's on almost every other postage stamp in Greece, but all the Greek postage stamps are written in Greek, so people don't know how to read them. Most people don't know how to read them. So they're busy trying to remind us of this great scientist, and people aren't listening. So what did he do? Well, he had heard, and I want you to, you're going to need your imagination here. He had heard, well, I'll help a little bit. Here's the Earth. Okay? And the Earth is spherical, they knew that part. And here comes the sunlight. And let's say it's the summer solstice, June 21st or 22nd, you're supposed to know that. So Eratosthenes had heard, and he lived in Alexandria, named after Alexander the Great, another very great Greek who conquered the Persians, Persian Empire, went on, conquered Mongols in the steppes of Asia, and then kept going. He ended up fighting and defeating the people in the Indus Valley, all the way in India, and he was fighting war elephants. So a very important person in the history of man, he by conquering those peoples, he also set up communication between them, between the cultures, and it led to quite a bit of growth for all the cultures that interacted with him. But he was certainly a leader of conquest. Anyway, Alexandria on the coast of Egypt was named after Alexander the Great, and that's where Eratosthenes was working. And they had a lighthouse there. They had lumber yards, which might not seem like a big deal to you, but imagine 2,000 years ago being able to go to a lumber yard and buy the wood you need. The wood was coming from Lebanon. Anyway, they had a lot of interesting things. Their art was superb. But Eratosthenes had heard further south along on the Nile River, there was a small little, just teeny tiny place called Syene. And it had a well. You might be wondering, why would you need a well if you live on the Nile River? Why would you need a well to get your water? And remember what lives on the Nile. You don't go near the banks of the Nile unless you absolutely have to. So they had a well, and this little town was called Syene. You don't have to know this, but the story is really important. He had heard that on the summer solstice, which is June, he had heard that if you go to the well in Syene and you look down the well, you'll see the reflection of the sun in the water, which of course means the sun is at the zenith. So where are you on earth if the sun is at the zenith on the summer solstice? The answer is, remember, Tropic of Cancer. Remember the Tropic of Cancer. What's the latitude of the Tropic of Cancer? Big number, 23.5 degrees. I hope you're getting these answers right. So the latitude of Syene must be on the Tropic of Cancer at 23.5 degrees, because if I look in the well, I see the sun reflected off the water. So Alexandria, where Eratosthenes lived, was not on the Tropic of Cancer. It was further north, so the sun never passed through the zenith. So he had some assistants go down there with poles from the lumberyard, and he made sure they knew how, using plumb bobs, or how to erect a pole in the ground vertically. And they checked, and sure enough, on the summer solstice, the shortest shadows occurred at noon, and the length of the shadow was 0. You could see sun all the way around the pole. There was no shadow for just a few seconds. So the sun was passing through the zenith, so he confirmed that. Same day, he was up in Alexandria, nice cool breezes, and probably enjoying a nice lemonade. But he also had a pole in his yard, and he measured the shadow, and the shadow did get short on that day, but it didn't go to 0. So let me draw a picture that'll help illustrate this. So here's the pole in Syene, and here's the pole in Alexandria. Exaggerated slightly. And so there would be no shadow from this pole, because that's the sunlight over there. But there would be a shadow here. And Eratosthenes is a Greek. Of course, he knows the length of the pole. He measures the length of the shadow. He knows this is 90 degrees. It's a right triangle. So therefore, he knows this angle. All this came from the Greeks, all this mathematics, trigonometry and geometry. So he knows this angle. And so if I complete this picture, these poles point to the center of the earth because they're vertical. And if I complete this, he knows this angle. And from your geometry class in middle school or high school, you know that that angle is the same as that. Opposite interior angles are the same. I know your head's starting to hurt right now. So these two angles are the same. If he knows that angle, he knows that angle. Hey, that angle is the angle between Syene and Alexandria. That's the difference in latitude. How many degrees are in a circle? So if this was 10 degrees, and it wasn't, I'm just using a round number, how many times would you have to do that to go completely around the world? Of course, the answer is 36, right? 36 times 10 is 360. So he didn't need to beg a king and queen for 3 ships to prove that the earth was spherical and to sail around the world. He only had to go, it was like 7 degrees, but we'll call it 10. He only had to go a short distance. But, so he knew the difference, he knew this angle. The problem is he didn't know the distance. So in just an amazing feat, he sent his assistants down again, but with a rope. They measured the distance from Alexandria to Syene using a rope. And they couldn't follow the Nile because the Nile turns and bends. They had to go out across the Sahara, cut across straight to get to Syene. They did a great job. They got the distance within about 2%. Can you imagine stretching a rope and then marking that and then stretching it again and marking it? How many rope lengths? We're talking from El Camino to Phoenix. So imagine I give you a rope. Okay, your assignment this semester is to walk to Phoenix with a rope and tell me how many rope lengths it is to Phoenix, Arizona. And don't follow the roads because they bend all over. You need to just travel straight. And they did it. So if you know this distance, then you multiply, in our example, you multiply by 36 and you have the circumference of the earth. So Eratosthenes determined the circumference. Of earth. And of course, if you have the circumference of the earth, you divide by that number. What is that? That's the Greek letter P. That's from the Greeks. They understood how important this number was. They measured it. And we know it. It's 3.14, 3.1415, and you can keep going. I think my daughter knows pi to about a dozen digits, something like that. But anyway, it's 3.14 to most people. So if we take this circumference and we divide by this number, and the Greeks knew it, that's their Greek letter P, we know the diameter of Earth. The Greeks, 2,000 years ago, it's still BC, 2,000 years, more than 2,000 years ago, the Greeks not only knew the earth was spherical, they knew how big it was. They made globes.